high performance liquid chromatography, HPLC. In the HPLC, liquid mobile phase is mechanically pumped to a column which has been packed with a given stationary phase. It employs a pressure device. This helps to move the liquid throughout the instrument. The other name of HPLC, high pressure liquid chromatography. HPLC can be classified according to mechanism of retention, can be classified based on modes of separation. HPLC classification based on mechanism of retention can be adsorption, partition, ion exchange, size exclusion, and affinity HPLC. It can also be classified based on modes of separation like normal phase HPLC, reverse phase HPLC. We have seen adsorption mechanism in thin layer chromatography, column adsorption chromatography. There is a competition between liquid mobile phase and a solid adsorbent for neutral solutes. Here the competition is for neutral solutes. The competition between liquid mobile phase and solid stationary phase. And partition HPLC also there. It is the competition between liquid stationary phase and liquid mobile phase. And size exclusion chromatography is there. Size exclusion HPLC. In that, stationary phase is a molecular sieve. Here stationary phase behaves as a molecular sieve that it can separates the molecules based on their size. Okay, here separation occurs based on the size of the molecule. And affinity HPLC, so which is much similar to our lock and key mechanism, which is prevalent in biological system, especially the drug and the receptor or the enzyme and substrate. So affinity chromatography, thereby, which is much similar to a lock and key mechanism. And ion exchange chromatography. So here ionic mobile phase is there, which is of a liquid containing ionizable species. And here is a stationary phase which can also be ionized. So there is a reversible exchange of the things, ionic species, between the liquid ionic mobile phase and solid ionic stationary phase. Here is a exchange of ions for similar kind of the species. Reversible exchange of the ions. These are different mechanisms we can achieve with the help of HPLC. And the type of HPLC to be selected is purely based on the type of the molecule being analyzed. For example, when I have to separate neutral solutes, I can choose either adsorption, partition, size exclusion, and affinity. Okay. So from adsorption to affinity, the techniques are suitable for neutral solutes. Neutral solutes in the sense here, these species are not ionic, these are electrically neutral. There is no cations. The molecule here existing as unionized. If I wanted to separate ionic species, if my sample is having more number of cations and anions, we'll have to choose ion exchange chromatography as a predominant mechanism of separation. The molecule may be inherently ionic, or it can be rendered ionic by adjusting the pH of the drug solution. In that case, we have to choose ion exchange chromatography. So the selection of the chromatography technique based on the type of the sample mixture being analyzed. Okay. So there are two broad options for selecting the chromatography technique. Okay. Whether the sample is neutral or ionic. If it is neutral molecule, if the mixture contains neutral molecules, you can choose either adsorption or partition or size exclusion or affinity. Okay. In this broad area, that is the separation techniques which are available for neutral molecules separation. Again, we have to think of what is the right method to choose for a particular type of the molecule. Here also, the nature of the species decides to select a particular chromatography technique. I said before, neutral molecules can be separated by any of the four chromatography techniques such as adsorption, partition, size exclusion, and affinity. Okay. And in turn, if my sample is having neutral molecules which have diverse physicochemical properties, that is, the difference in their chemistry is wide. Here the species differ by their wide chemistry. In that case, we can deliberately select adsorption chromatography. Okay. So ఆ శాంపుల్ మిక్చర్లో మాలిక్యూల్స్ మధ్య కెమిస్ట్రీ పరంగా వ్యత్యాసం ఉంది, డిఫరెన్స్ చాలా ఉంది. సో అలాంటప్పుడు నాకు అవైలబుల్గా ఉన్న టెక్నిక్స్లో మనం అడ్జాప్షన్ చూస్ చేసుకోవచ్చు. అలాగే నా దగ్గర శాంపుల్ ఎలాంటిదంటే, ఈ కాంపౌండ్స్ అన్నీ కూడా ఫిజికో కెమికల్గా ఒక్కటే. దేర్ కెమిస్ట్రీ or their physicochemical properties are nearly same. It is obvious that no two compounds have exactly same physicochemical properties. That is why I am mentioning that their chemistry or their physicochemical properties are nearly same. So in that case, partition chromatography can resolve that type of the conflict. It can. Okay. Because here the solutes have close in their chemistry. For example, when you are separating a group of amino acids, so we are calling them as amino acids. Presence of amino group, presence of carboxylic acidic functionality, all the amino acids possess this type of behavior. Tetraionic behavior. For example, I am selecting the amino acids as group of molecules which are having unique feature like tetraionic nature, but which are different with respect to each other, but they are having a similarity like formation of tetraion. Okay, such case partition can answer this type of the challenge. Okay, so that if your sample is having homologous series, the sample having the things which have similar kind of the physicochemical properties, you can select partition chromatography. So sometimes if a mixture having maybe few number of components, here we can perform adsorption or partition. Since the number of compounds present in the mixture are few, it is very less number of compounds. So in that case, we can rule out the general algorithm. Okay, that we can select either of the techniques. Okay, hope that you have understood how to select a particular chromatography technique so far. Okay, and again we have another two chromatography techniques left. So please observe. So these two kind of techniques have something speciality. Call it as the sample nature is special. Okay, why I mentioned here it's special? Because neutral sample is a regular sample. In that, if ionic species are there, we never choose adsorption partition chromatography techniques. We which are not suitable for separation of the ionic species. We have a definite technique called ion exchange chromatography. It answers well regarding that sample. Okay. Whereas I mentioned here, when I was mentioning special sample, you might have a doubt how the special samples exist in analysis. It's nothing else. In contrast to synthetic molecules, we have biomolecules. Which are considered to be the special case of the sample. Okay. Some of the molecules are there, though their origin is synthetic, but they are much bigger in their molecular size. Such type of samples may also be treated as special kind of the sample. Okay, per se, polymers, organic polymers. Okay. I don't know whether inorganic polymers exist. Organic polymers. So when I take any given number of polymers, it is of a chemical entity only. Its molecular size is sufficiently high that greater than perhaps 2000 Daltons or perhaps 5000 Daltons. And large biomolecules like proteins, albumins, globulins, and peptides. These kind of the biomolecules have large molecular size, which cannot be separated by either adsorption or partition. Such type of the samples can be analyzed by size exclusion chromatography. Okay. The other name of this technique is called gel chromatography. You might have heard about this word, gel chromatography. So the term itself indicates some of the gel-like materials. Here, gel means not aerosolutics preparation. Okay. Here gel indicating a polymeric bed. Okay. So this gel chromatography separates the molecules which have large molecular size. It cannot be separated by any other techniques like vapor chromatography, thin-layer chromatography, which cannot. Okay. Therefore, some special kind of the molecules only, or the molecules which have above 500 Daltons molecular size, molecular weight, which can be successfully separated by size exclusion chromatography. And some of the ligands, you might have heard ligands, substrates, enzymes, coenzymes, can be separated by affinity chromatography. Affinity. Since the mechanism involved in affinity chromatography is much similar to the lock and key mechanism which is prevalent in biological system. Here. Okay. I have studied about lock and key mechanism, enzyme and substrate theories. Okay. Similarly, drug and receptor. Okay. Such type of the models obeys specificity as well as affinity. Okay. One enzyme or one substrate or one enzyme is a specificity. Similarly, one drug should bind to one receptor is also the specificity. Such a type of the specific samples can be separated. For example, ligands. The ligands can be adhere or bind to a particular substrate. So in the case of purification of ligands, enzymes, coenzymes, cofactors, affinity chromatography can be used. Okay. Hope that with this chart you have learned something regarding selection of a particular chromatography technique based on the nature of the sample. Okay. Right? Okay. When we go the mechanisms individually, adsorption chromatography, as I mentioned before, it is a competition for neutral solutes between liquid mobile phase and solid stationary phase. Okay. We had a discussion on column chromatography before. In that, I was mentioning things separated here. Here the species separates based on the premise like, likes, like. Here, likes, like. If you do remember this premise, it means like dissolves like. In particular way, then we have to say polar solutes will be retained longer by polar stationary. Please meditate this sentence. Polar solutes will be retained longer time by polar stationary phases. We have two important things I was mentioning. Polar solutes. In the case of column chromatography also we taught polar solutes. We have seen polar stationary phases. Okay. Since polar and polar. Okay. What would be the affinity between polar and polar? Can anybody say? వీక్ ఆర్ స్ట్రాంగ్ అనేది ఒకసారి అబ్జర్వ్ చేయండి. అంటే నేనేం చెప్తానంటే పోలార్ సొల్యూట్స్ ఉన్నాయి అంటే సొల్యూట్స్ అంటే ఇక్కడ శాంపిల్స్ మాలిక్యూల్స్. స్టేషనరీ ఫేజ్ ఏముందండి ఇక్కడ? పోలార్ స్టేషనరీ ఫేజ్. ఇప్పుడు ఈ పోలార్ పోలార్ ఇంటరాక్షన్ అనేది లేదా మ్యాగ్నిట్యూడ్ ఆఫ్ పోలార్ పోలార్ ఇంటరాక్షన్ అనేది ఎలా ఉంటుందని మీరు ఒకసారి ట్రై చేయండి. స్ట్రాంగ్గా ఉంటుందా లేదా వీక్గా ఉంటుందా అని ఒకసారి మనం మాట్లాడుతున్నాం ప్రీవియస్ క్లాస్. ఓకే. పోలార్ సొల్యూట్స్ అండ్ పోలార్ స్టేషనరీ ఫేజెస్ మధ్యన ఉండే అట్రాక్షన్ అనేది లేకపోతే ఇంటరాక్షన్ అనేది ఎఫినిటీ అనేది మనం ఎన్ని పేర్లు పెట్టినా ఒకటే ఇక్కడ. ఇంటరాక్షన్ బిట్వీన్ పోలార్ సొల్యూట్స్ అండ్ పోలార్ స్టేషనరీ ఫేజ్ వుడ్ బి స్ట్రాంగ్ ఎనఫ్. దట్ ఈస్ ద మీనింగ్ ఆఫ్ లైక్ లైక్స్ లైక్ ఆర్ లైక్ dissolves like. Similarly, non-polar solutes will be best retained by non-polar stationary. Retain and ఇక్కడ is the meaning of retain. It will be held best by the polar stationary. అయితే క్రోమటోగ్రఫీలో మనకి కావాల్సింది ఏంటంటే కాంపౌండ్స్ సెపరేట్ అయి బయటకు రావాలి. బట్ ఇది స్ట్రాంగ్ గా ఎఫినిటీ ఉందంటే ఎందుకంటే లైక్ వన్ లేకపోతే మీరు తెలుగులో ఏమి ఉంటారు ఏ గుడి కోసం లేకపోతే చేరతాయి అంటారు కదా. అలాంటప్పుడు మన సెపరేషన్ ఎలా జరుగుతుంది మరి? ఎందుకంటే ఇదేమో పోలార్ సొల్యూట్స్ పోలార్ స్టేషనరీ కానీ ఈ రెండింటి మధ్య ఇంట్రాక్షన్ చాలా స్ట్రాంగ్ గా ఉంటుంది. అప్పుడు ఏమవుతుంది కాంపౌండ్ ఏంటంటే స్ట్రాంగ్ గా లేకపోతే ఫర్మ్ గా స్టేషనరీ ఫేజ్ పట్టుకొని ఉంటుంది. దీన్ని మనం బ్రేక్ చేయగలిగితే సెపరేషన్ మనం అచీవ్ అవ్వచ్చు. జాగ్రత్త గమనించండి. ఇది బ్రేక్ చేయాల్సిన చూడండి ఒకసారి. పోలార్ సొల్యూట్ ఉంది, పోలార్ స్టేషనరీ ఫేజ్. అప్పుడు వాటి మధ్యన ఇంటరాక్షన్ లేదా ఎఫినిటీ అనేది చాలా ఎక్కువ ఉంటుంది. పోలార్ ఇంటరాక్షన్ would be strong enough. Similarly, non-polar interaction would be strong enough. Whereas the type of the interaction between polar solutes and non-polar stationary phase would be it leads to a weak attractive forces. Okay. So that we'll have to break down this type of the polar interaction. Somebody wanted to talk? Is anybody wanted to ask something? Please or no? Yes? Right. So here is a polar molecules depiction like alcohols, acids, carbonyls, salts. This comes under polar type of the molecules. Yes. And then you see non-polar molecules like aliphatic hydrocarbons, halogenic, aromatic. These are something called non-polar molecules. Okay. I mentioned before class what is the nature of the stationary phase in normal phase chromatography. What is the nature of the stationary phase in reverse phase chromatography? Okay. We need to gather answer for this question. Okay. So just like adsorption partition also a competition. Okay. It is also a competition for neutral solutes between liquid stationary phase and liquid mobile phase. As all of us know that partition is a liquid separation. Okay. Keep remembering this algorithm. When I write L/L, liquid separation. This first L stands for stationary phase is liquid, mobile phase is also liquid. Okay. But it is very difficult to prepare liquid stationary phases in chromatography because support is needed to hold the liquid stationary phase. That is the main drawback while manufacturing liquid stationary phase. However, long chain alkyl chain bonded phase columns have been developed These long alkyl chains are considered to behave like a liquid. But remember that it is very difficult to prepare liquid stationary. In the case of gas chromatography, high boiling organic liquids can be coated on the surface of the diatomaceous CO2 particles. The type of the stationary phases so conveniently packed or coated on the inside of the column layer in the capillary column. So that is the case in GC, but in the case of HPLC it is not possible. Okay, that is why solid stationary phases are most common in liquid mobile phase. As usually it is pumped through the instrument with the help of device, pressure device. Ion exchange chromatography. When you see the principle behind ion exchange chromatography, what is happening here? Reversible exchange of ions. Okay, exchange. See, reversible exchange of ions between the ions present in the mixture and the ions present in the stationary phase. Remember, stationary phase here is also an ionic species. Okay. Then please let me know the exchange must be between a similar kind of the ions or different kind of the ions. చూడండి ఎక్స్చేంజ్ అనేది ఎలా ఉంటుందని మీరు అబ్జర్వ్ చేయండి. జీవితంలో కూడా ఎక్స్చేంజ్ అనేది ఎలా ఉంటుంది. ఫర్ ఎగ్జాంపుల్ ఇద్దరు ఫ్రెండ్స్ ఉన్నారు. ఒక ఫ్రెండ్కి చైనా ఫోన్ ఉంది, ఇంకొక ఫ్రెండ్కి ఏమో ఐఫోన్ ఉందండి. ఇతను చైనా ఫోన్ అతనికి ఇచ్చి అతని దగ్గర ఐఫోన్ ఇతను తీసుకున్నాడు అనుకోండి, ఎక్స్చేంజ్ అవుతుందా? చెప్పండి, ఎవరో ఒకరు చెప్పవచ్చు, అన్మ్యూట్ చేసుకుని మీరు. ఇట్ ఈస్ నాట్ ద యాక్చువల్ రియల్ ఎక్స్చేంజ్. ఓకే, ఎక్స్చేంజ్ అనేది ఎలా ఉండాలంటే ఈ గూడ్ ఎంతైతే ఈ వస్తువు ఎంతైతే వాల్యూ ఉందో అంతే వాల్యూ ఉండే వస్తువు తీసుకోవాలి, అప్పుడు మాత్రమే ఎక్స్చేంజ్. ఇక్కడ కూడా ఏంటంటే అయాన్స్ మధ్యన ఎక్స్చేంజ్ జరుగుతుంది. సిమిలర్ కైండ్ ఆఫ్ ద అయాన్స్. ఓకే, ఇక్కడ శాంపుల్లో అయాన్స్ ఉన్నాయి, స్టేషనరీ ఫేజ్ లో కూడా అయాన్స్ ఉన్నాయి. దాని ద ఎక్స్చేంజ్ మస్ట్ బి బిట్వీన్ ions present in the mixture and the ions present in the ion exchange resin, nothing but the stationary phase. Okay, that's it for today class. What is learned today? So we have learned what is a liquid chromatography. As Hplc is a term used high performance liquid chromatography. Yesterday class we have learned what is performance, what is efficiency, okay, what is liquid chromatography. Today class we have seen different kinds of Hplc mechanisms, how to select particular chromatography technique based on the nature of the sample. We have seen exhaustion mechanism as well as partition and ion exchange techniques. Okay. Coming class I will discuss the rest of the mechanism and how Hplc instrumentation is manifested. It is normal phase and reverse phase chromatography. I have given an assessment for you how why reverse phase chromatography attains more popularity and compared to normal phase chromatography.